Bismillahirrahmanirrahim. Assalamu alaikum, students. Today we are going to discuss another problem. So let me give you the problem, then we will discuss the solution together. So the problem is the magnitude of the average electric field normally present in the Earth's atmosphere just above the surface of the Earth is about 150 Newton per Coulomb, directed downward. Let me use another color. What is the total net surface charge carried by the Earth? Assume, let me use another color. Assume the Earth to be a conductor. This is our today's problem. Let me check it, then we will discuss the solution. The problem says the magnitude of the average electric field normally present in the Earth's atmosphere just above the surface of the Earth is about 150 Newton per Coulomb directed downward. What is the total net surface charge carried by the Earth? Assume the Earth to be a conductor. So let us move to the solution. Let me use this color. So the solution goes like this. If we have some conductor of arbitrary shape, if it is some conductor and we give some excess charge to it, excess or net charge to it, that can be positive or negative. Now what happens? That charge distributes over the surface of the conductor. I repeat, if I have some conductor of any arbitrary shape and I give it to some excess or some net charge to it, positive or negative, that charge distributes over the surface. That is the property of the conductor, and none of that charge, excess charge, is found within the body of the conductor. You can prove that, for example, using Gauss's law. Another thing is, if the conductor is spherical in shape, then the excess charge given to it or net charge given to it distributes over the surface uniformly. That means surface charge density sigma, the SI unit of which is coulomb per meter square, for a spherical conductor is constant for the surface, but for non-spherical conductor, sigma varies from point to point. At sharper surface regions, sigma is large. At flatter regions, sigma is small, right? This is the property of the conductor. Now, if at certain point P of the surface, if the surface charge density is sigma, then electric field just outside that point due to the charge is sigma by epsilon naught. I repeat, if at some point P on the charged conductor, surface charge density is sigma, then electric field just outside that point is sigma by epsilon naught. And another thing, that electric field is perpendicular to the surface. If the surface charge density is positive, it will be outward directed. If it is negative, it will be inward, but it will be perpendicular to the surface there, right? Now, keeping this in mind, we can solve our today's problem. So we are given, let me use some color, another color. So I have Earth, this is my Earth. The first thing is, the problem says assume Earth to be a conductor. So it's my conductor, right? Now I have to find the net surface charge carried by the Earth. So let Q be the net surface charge carried by the Earth. So let Q be the net surface charge carried by the Earth. Now, Earth, assuming Earth is spherical, this charge will be distributed over the surface of the Earth uniformly, right? So let R be the radius of the Earth. Now it is given that the magnitude of the electric field above the surface of the Earth is given. It is 150 Newton per coulomb. Magnitude of E is 150 Newton per coulomb, and it is directed downward. It is directed. So suppose I show some position. So electric field is directed downward, right? And as I said, it is perpendicular to the surface. It is directed downward. Now, therefore, as you know, lines of force terminate on negative charges, so that if Earth's electric field points downward, its average surface charge density must be negative. So sigma is negative. I repeat, since electric field is directed downward, and we know lines of force terminate on negative charges, so the average surface charge density sigma of the Earth must be negative. So making use of this relation, we can find sigma. So sigma is epsilon times E. Epsilon is permittivity of free space. Its value is 8.85 into 10 raised power minus 12 coulomb square per Newton meter square times the value of E, which we take negative. By negative would mean it is directed downward. So I take it minus 150 Newton per coulomb. So when we do the calculation, it turns out to be minus 1.33 into 10 raised power minus 9, write it neatly, minus 9 coulomb per meter square. This is my sigma, average surface charge density of Earth. Let me check it. Epsilon times E. Epsilon is 8.85 into 10 raised power minus 12 coulomb square per Newton meter square times this E, which we take negative because it is directed downward, which is minus 150 Newton per coulomb. So sigma turns out to be minus 1.33 into 10 raised power minus 9 coulomb per meter square. As always, check the calculation at home. But we have to find Q, the net surface charge carried by the Earth. So Q is simply sigma times 4 pi r square, where r is the radius of the Earth. We're assuming it is perfectly spherical. 4 pi r square is the surface area of the Earth, where sigma is charge per unit surface. It is total charge on the Earth over its surface area, 4 pi r square. So the total charge Q is simply sigma times 4 pi r square. R is the radius. So let me put the numbers. Sigma we have calculated is minus 1.33 into 10 raised power minus 9 coulomb per meter square times 4 pi times the radius of Earth is 6.37 into 10 raised power 6 meter. Then there is square, where r, the radius of Earth, is 6.37 into 10 raised power 6 meter. So Q is sigma times 4 pi r square. Sigma is minus 1.33 times the 10 raised power minus 9 coulomb per meter square times 4 pi times 6.37 into 10 raised power 6 meter whole square When we do the calculation, it turns out to be minus 680 kilocoulomb. So Q is minus 680 kilocoulomb, and you know 1 kilocoulomb is 10 raised power 3 coulomb. So this total charge possessed by the earth is Q, which is minus 680 kilocoulomb. Check the calculation. This is our answer. So let me summarize the problem. We are given the electric field normally present just above the surface of Earth as 150 Newton per Coulomb, and its direction is also specified as directed downward. We are asked to find net surface charge carried by the Earth, and it is said that assume Earth to be a conductor. Then we said if we have some conductor, it has some excess or some net charge, positive or negative, that charge distributes over the surface of the conductor. If the conductor is spherical in shape, then charge is distributed uniformly over the surface. That means surface charge density sigma is constant throughout the surface for a spherical conductor. But if it is of some non-spherical shape, then sigma varies over the surface. For pointed regions, sigma is large. For flatter regions, sigma is small. Now suppose at certain point of the surface P, the surface charge density is sigma, then the electric field just outside that point is sigma by epsilon naught, and that is perpendicular to the surface. If the surface charge density is positive, it is outward normal. If it is negative, it is inward normal. Now we assume the Earth to be a conductor. It has certain radius. Electric field just outside the surface is given. It is directed inward. It is perpendicular since it is inward, and we know lines of force terminate at negative charges. Therefore, the net charge carried by Earth must be negative, and we use it E is equal to sigma by epsilon naught. To solve for sigma, we took E as negative 150 Newton per Coulomb because it is directed downward. Upward, we take positive direction. Downward, we take negative direction. Then we solve for sigma. Then using the 4 pi r square for the surface area of the spherical Earth, we solved for Q, which is our answer. So this is all for today. I hope you enjoyed this problem and you are enjoying all the problems we have discussed or shared on the YouTube. So don't waste your time, go through all the problems, and you can do much more problems your side by yourself as well using some good textbook. And don't forget to like, share, and subscribe my channel. You can give comment in the comment box. If you subscribe the channel, you have one advantage that you will get the notification whenever I upload some new video on the YouTube. Thank you. God bless you. Assalamu alaikum.